Okay, well, here's my copy of the PDF file, and we're looking at 6 points. The summary of the evidence for intelligent design. There are 6 points in our video, and the first one I said was the weakest one. That's what we call the local fine-tuning. That's the fine-tuning of conditions on Earth. I'll explain why that's probably the weakest point as far as pointing to design. Then we went into the second point, which many people think is the strongest point. I think there are a bunch of strong ones we're going to talk about, but many scientists, let's say it's the strongest non-controversial argument for God. In fact, in my book, I have a quote from Robert Jastrow, who is a Columbia University astronomer, and he said this is this fine-tuning that we're talking about in point 2 is the most theistic result ever to come out of science. Well, I think there's a bunch of others too, but anyway, you can see that it has actually convinced a lot of scientists, and it's not really controversial in the sense that everyone recognized, including Stephen Hawking. We quoted from him. Atheists acknowledged that the basic parameters of physics are extremely fine-tuned. We're extremely lucky if most any of them were changed by a small amount. Something terrible would have happened. Usually there's no chemistry, nothing but hydrogen or no stars. And if there's no stars, you're not going to have energy for life, and you're also not going to have, as someone pointed out last time, you won't have anything heavier than hydrogen because all the heavier elements are constructed in the stars. So anyway, something really terrible will happen. We're not just talking about things that would make life as we know it impossible. We're talking about things that can make any conceivable form of life impossible. And some of these parameters, speed of light, Planck's constant, charge of the electron, mass of the electron, and a bunch of others, gravitational constant. Some of them could have varied by a few percent and we could have still survived, but some of them had to be really, really exactly what they are. And we looked at several videos. If you weren't here last time, you might want to go through and look at some of those, but I'm going to look at one more now. This is only a two-minute segment of this privileged planet, which is, as you can see, one of my favorite videos. It's an hour and a half long, but got some really good stuff in it. So I just click on this and need to shut it off. I want to go till the 50-minute. It starts automatically where I want it to, and then I go to where I want it to. So
the spectacular progress of modern astronomy and physics is the product of a universe accessible to the human eye and mind. It is a universe governed by laws and forces that literally hold our planet Earth and the entire cosmos together, and are finely calibrated to allow for both complex life and scientific discovery.
If you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You would have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
During the past 40 years, scientists have determined the relative strengths of each of these primary laws and forces. These strengths are so critically balanced, they are often described as being finely tuned.
If you're to take the basic fundamental constants of nature and you were to change these even slightly, or you were to pick their values at random, you would almost never get a universe that would be habitable in any sort of way. That is, you couldn't have galaxies, you couldn't have planets, you couldn't have complex biological organisms if these fundamental constants were even slightly different, slightly stronger, slightly weaker than they actually are in this universe. That's the idea of fine-tuning.
To better appreciate this concept, Imagine a machine able to control the strengths of each of the physical constants. If you changed, even slightly from its current setting, the strength of any one of these fundamental forces, such as gravity, the impact on complex life would be catastrophic.
Okay, well, we've seen several examples of this fine-tuning, but we looked at this video last time, and there was one number in particular I wanted to look at here. I'm going to go back to this video, which we already, so you don't need to download this one. It's already it's already on the. But I just want to look at one particular aspect of fine-tuning that we did talk about it last time.
1/20 parts would cause the universe to expand too rapidly.
Okay, so they're listing a few of the parameters that are fine-tuned. Basically, they just list the ones that are most spectacularly fine-tuned. But
Slowly. In either case, the universe would again be light prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd.
yeah, that's the we talked about this last time, but I'm going to go into it more now. So I only have a vague idea, actually, of what this is all about, but this was basically these numbers come from Roger Penrose. They appear in a lot of different books. Steve Myers talks about it. I've seen it in several others, so it doesn't seem to be too controversial. Certainly, it's possible that it's wrong, but anyway, it's fairly widely accepted that basically this particular aspect of fine-tuning, which has to do with the initial conditions at the Big Bang, is incredibly improbable. Now, to get an idea, 1 part in 10 to the 10 to the 123, we talked about that last time, and Roger Penrose himself is going to mention it here, but that basically means a 1 followed by more zeros than there are atoms in the universe. And I'm just going to call that infinity minus 1 because it's so large. I don't want to keep repeating that, but it's an incredibly large number. That's the probability, according to Penrose, of 1 over that is approximately the probability of that order of the universe being life-supporting. So keep this in mind when we look at another video that I haven't shown yet, which is an interview with Roger Penrose himself recently. I think it's 2019 interview. Let's see. He is a Nobel Prize winner. I think he won the Nobel Prize in 2020, which is for work much earlier, I believe. But in any case, he's the source of this number here. He's the one that did the calculations. You have to believe anything a Nobel Prize winner says, right? So the probability of our universe supporting any kind of conceivable life is unbelievably small. And yet, let's see what, even that doesn't convince a lot of scientists. Well, it does convince many, but let's basically what Roger Penrose says is he kind of avoids the question. William Lane Craig, who's I'm told is a Christian mathematician, is kind of interviewing him or debating him, but it's a nice debate. And they're talking about fine-tuning. And the interesting thing is that, you assume that Roger Penrose at least believes his own numbers, that basically 1 over infinity is the probability of the universe supporting life, and he doesn't even believe in the multiverse. Well, we talked about the multiverse last time. That's basically the atheist's only counter to fine-tuning, is saying, well, there must be many universes with random values for all these parameters, and well, we talked about that last time. But anyway, he doesn't even support that, and I'm not sure why. Maybe he thinks it's a bit much to talk about that many other universes. But anyway, let's see what he gives us his explanation.
Well, in the contemporary literature on fine-tuning, there are basically 3 explanatory options. either physical necessity, that these constants and quantities must have the values they do, that it's not contingent, or secondly, chance. And the form that this normally takes would be a kind of multiverse hypothesis, and then an appeal to an observer selection, self-selection effect, that we can only observe universes that are finely tuned for our existence. So we shouldn't be surprised that somewhere in the infinite multiverse that we should appear in such a universe. And then the third one would be design, that there is an intelligence that has designed the universe. And Roger's a special contribution, I think, to this has been to place a very significant objection and question mark behind the explanation of the multiverse hypothesis with the self-selection effect. Because if we were just a random member of a multiverse, we ought to be observing a much different universe than we do.
I want to come to that. I mean, first of all, on this question of fine-tuning, which again, we might be worth just spelling out a little bit for the audience. Yes. You've yourself have contributed interestingly to this. There's a certain aspect of reality, the initial low entropy distribution of mass and energy. Now, yes. Without getting too technical at this point, this is essentially the idea you were sort of alluding to earlier, that at that very earliest moment, that singularity in Big Bang cosmology, there's an incredible amount of order versus the disorder, the entropy that appears later on, that needs to be there in order for a life-sustaining universe to be possible. In fact, you put this extraordinary number on it of the precision needed to be 1 in 10 to the power of 10 to the power of 123, which I'm told is, if you were to try to write that down there and you put a 0 on every single particle in the observable universe, you still wouldn't have enough zeros.
Nowhere
on this.
Close.
and so yes. This is mind-boggling stuff, but it appears as though someone, as you know, who was it who said that someone's been monkeying with the physics? Hoyle, Fred Hoyle said it looks as though, as Bill has said, some sort of design is there to ensure that we got here. Now, what do you say to that idea?
Well, I'm agnostic, I would say, on that one. You see, it's not clear to me. I mean, people talk about well, even the mass ratio between the proton and the neutron, and the fact that the neutron is just a little bit more massive than the proton, and it goes that way rather than the other way around, and so on. But it's very difficult to, since we only know one kind of life, you see, or one kind of the production of consciousness, it may be very rare throughout the universe. I mean, the numbers may not all be all that good. You see, you can imagine fiddling with them so that there were consciousnesses all over the place. You see, I don't know. You see, we don't know enough about that, and there are some nice examples from science fiction which show different I like the one, Fred Hoyle's idea of the black cloud, you see, where this was a completely different way of imagining a conscious being, which was this huge cosmic cloud which communicated, I guess, by electromagnetic signals and things like this. The other story which I like to refer to is one by Robert Forward, which was a Dragon's Egg, I think was the name of the story, where there was a neutron star which came close to the sun, and the people on the Earth went to explore it, and it turned out that there were living beings on this neutron star, which instead of using chemistry, they used nuclear processes. And this means that their lives and evolution took place millions of times faster than us. And how you can make a story with this complete imbalance was an amazing achievement, I thought. But they even had a religion which took place in the Cheelers, which were the inhabitants of this neutron star. And when the Earth thing came close to them, they built their complete religion on the star, which appeared, you see, in the
So do you think it's I mean, these are obviously stories, but do you think it's possible in a sense that some sort of conscious reality could exist even in the absence of the physical sort of
Well, it could have-
carbon-based life that we obviously need. For,
It could have been done very differently, in a totally different. You see, there are many different parts of the universe where the physics is very different from what it is on the Earth, and maybe a different kind of life could have evolved there. And I have no idea. Just that we don't know. There are puzzles,
right?
Which look like coincidental things. And one of the first ones was Hoyle's thing about the energy level of carbon, which if it hadn't been there, then you couldn't have got beyond evolution.
Well, Bill, what's your response to these sorts of ways of dealing with the fine-tuning?
Well, this is fascinating to me because, as I understand you, Roger, you're not advocating either physical necessity nor chance via the multiverse hypothesis and self-selection effect, nor design, but rather you would simply deny the fact of fine-tuning altogether, that the universe is not fine-tuned for embodied
I think deny is too
consciousness.
strong. I say I don't know.
You don't know.
Yeah.
And to me, that is highly implausible. We just find example after example of fine-tuning in contemporary physics, and it seems to me to be a desperate expedient to deny that it exists. In the absence of fine-tuning, there wouldn't even be matter. There wouldn't be chemistry. So the idea that other forms of life would evolve, I think, is logically possible, but it's not, I think, the most plausible solution to the problem.
Well,
Okay, I just included that. I added this recently. I happened to notice it mainly because it shows how strong the opposition to design is. I mean, he did say he was agnostic to it, but if I thought the probability was infinity minus one, as I called it, to one over that, I'd at least take design a little more seriously. And well, I do. Anyway, so that that's a Nobel Prize winner, and that's the. Well, he's not. It shows the opposition to design among scientists, which I understand, but it's not based on, certainly not on fine tuning, and I don't think it's based on the evidence in general, as we'll see, but it's based on other things. The problem of pain is if everybody was happy, there'd be a lot more intelligent design people in the world probably, and mainly just the fact that science has been so successful in other areas. Scientists today are so used to finding solutions to everything that they think they can explain everything, even including God. And if they can't explain God, then God can't exist. We'll talk about that in part number 6. But anyway, it's important for Christians to know that the opposition to design is not really based on new discoveries that eliminate design. It's the opposite. The design hypothesis, the God hypothesis, is making a comeback now because of new scientific discoveries, as Steve Meyer's book says. So now I want to go into what I'm calling point 2B, which is the second part of the global fine-tuning thing, which is basically counter to the multiverse. In other words, if you were here last time, you know that the only explanation scientists, atheist scientists anyway, have for the fine-tuning is to say, well, there must be many universes with random values of who knows what, and we're here because let's look in fact at one of the sources we quoted in the original video. A.J. Leggett, let's see. Yeah, he's in explaining how come the basic constants of nature are so lucky. The anthropic principle then turns this statement around and says, in effect, that the reason the fundamental constants have the values that they do is because otherwise we would not be here to wonder about them. So that's the, that's basically the explanation that you have to go with, although Penrose doesn't, but for both the local and the global fine-tuning. And the local fine-tuning, it works a lot better than it does with global fine-tuning. In other words, you can explain, maybe it makes sense that you can explain why we're on a planet with such nice properties, life-supporting properties, by saying, well, if it didn't, we wouldn't be here. Well, I mean, that's true. And there are lots of other universes, lots of other planets. So it's reasonable to think maybe that, there are enough planets that some of them are, well, we know at least one going to be life-supporting. So it's basically the same argument that was used in the local, to explain away the local fine-tuning. But it's much harder with the global fine-tuning because we have no evidence that there are other universes. We talked about all this last time. But anyway, point 2b is basically a counter to that. And I want to quote from Michael Behe because I think he's got the best explanation for what this is all about. And actually, the Penrose, at the first couple of minutes of Roger Penrose video, William Lane Craig actually mentions this, and that may be the reason that Penrose doesn't bring up the multiverse hypothesis, because apparently he's made the similar argument to what Michael Behe does, except that he doesn't, I guess, conclude design. But anyway, so here's what Michael Behe says about basically the multiverse explanation. I almost hate to talk about this because it's taking it more seriously than we probably ought to. Maybe we should just leave it and say, the only possible explanation is there are many other universes, and that's not scientific. So, but even if you believe that, Behe outlines what is basically the counter to that. So let me read this. He says, suppose that in a large room were gathered together everyone who had won a prize in the past year in the Powerball lottery, no matter how large or small. They were all voice is getting bad. They were all having a party closed to the public. You sneak into the guarded room and meet someone at random. What are the odds that the first person you meet is a big money winner? Very slim. The great majority of folks there will be minimum or small prize winners. That is, a person selected at random from the winners category will be very likely to fulfill just the minimum requirements for getting into the room. The same goes for universes. On the finite random multiverse view, we should very likely live in a bare bones world with little or nothing in life beyond what's absolutely required to produce intelligent observers. So if we find ourselves in a world lavish with extras with much more than the minimum, we should bet heavily against our world being the result of a finite multiverse scenario. It is difficult to make a rigorous argument on such a question, yet it seems that our world is quite lush and contains much more than what's absolutely needed for intelligence. Actually, the fine-tuning video alludes to that in the second part that we didn't show in here, and the Roger Penrose alludes to this also, but Behe states it more clearly. So let me review what the argument here is. That this is the argument against the multiverse as an explanation for fine-tuning. For fine-tuning, local fine-tuning or global fine-tuning, really, it applies to both of them, because the multiverse argument basically says, as Leggett says, otherwise we wouldn't be here if the constants are what they are, because otherwise we wouldn't be here to observe it. Well, Behe is pointing out that the world is a lot more than just what we need to have conscious observers. Okay, well, first of all, as we mentioned last time, this all assumes that once you have a planet with right conditions, and once you have a universe with the nicely tuned laws, nicely tuned constants, then there's a reasonable chance, maybe small but reasonable chance, that life could appear, intelligent beings would evolve, and they would become conscious. And I don't believe any of those. We're going to talk about that in points 3, 4, and 5. But let's, as they say in legalese, let's stipulate that. Let's assume that that's true. Then the argument against design kind of makes sense for the local fine-tuning, but not the global fine-tuning, because, as Behe says, there's a whole lot here that goes beyond what's needed to just have conscious observers. In other words, the multiverse argument is supposedly explains why there are conscious observers, because otherwise, I mean, the parameters are what they are, because otherwise there wouldn't be any conscious observers. But Behe points out that it seems like our world is a whole lot better than that, than the minimum required. And that's what we're going to talk about now. He says it's difficult to make a rigorous argument, but actually some people are trying to do that. It is difficult, but I've got 2 videos I want to watch here, and got just about enough time, that illustrate how this counters both the explanation for why our Earth is so well suited to life and the argument for why our universe is so well suited for life. It kind of blows them both out of the water. And first video is by Michael Denton, Firemaker, and I want to get 2 different segments here, and then we'll talk about it.
If humans had not learned to harness fire, the world as we know it wouldn't exist. It was the mastery of fire that allowed the development of technologies on which our modern lives depend. Fire enabled cooking, which made it easier for early humans to digest food and gain the calories they needed to nourish their large brains. Fire enabled ceramics, which led to the production of pottery, pipes, bricks, and tiles. Fire led to the creation of glass, which produced glassware, windows, plate glass mirrors, and eyeglasses. And fire led to the rise of metallurgy, which allowed us to transform raw ore containing copper, iron, and other metals into utensils, weapons, and tools. Metallurgy in turn led to one invention after another. Metal nails, steel, printing presses, steam turbines, telegraphs, internal combustion engines, light bulbs, telephones, automobiles, televisions, computer chips. In short, humanity's mastery of fire was the initial domino that produced a succession of innovations leading to the world we know today. But as critical as fire is to the world we live in, its miraculous powers couldn't have been harnessed just anywhere or by just anyone. In fact, there's only one known planet in the universe designed to reap the benefits of fire: Earth. And there's only one known animal capable of harnessing the power of fire: humans. In order for our planet to fully realize the life-giving powers of fire, a multitude of precise and exacting conditions had to be met. First, our planet had to have the right kind of atmosphere, one that permits both the existence of fire and the existence of a biological creature capable of using it.
You need to have an atmosphere that supports both biological respiration and combustion. And it seems, well, all atmospheres would be like that, but that's not correct. There's various types of atmosphere with different proportions of nitrogen and oxygen, different atmospheric pressures, in which we could breathe and survive okay, but you couldn't make a fire. And there's many atmospheres like that. So the first thing you need an atmosphere in which we can breathe and which can also support fire. That's condition number one.
But to get the right kind of atmosphere, you also need a planet of just the right size.
You need to have a planet about the size of the Earth. So why do you need a rocky planet like the Earth? You need that because if the planets much larger than the Earth retain their primeval atmospheres, that is, they retain hydrogen and helium, light gases, and the conditions on large planets are incompatible with the sort of atmosphere we have.
Only planets of the right size can possess an oxygen-rich atmosphere, which is required if you want to have both respiration and combustion. Planets much larger than the Earth, like Jupiter, retain light gases like hydrogen in their atmospheres by their strong gravitational pull, and cannot undergo planetary and atmospheric evolution into a rocky planet like the Earth with an oxygen-rich atmosphere. Planets much smaller than the Earth, on the other hand, can't maintain free oxygen for another reason. A small planet's gravitational pull is so weak that oxygen molecules will float away into space. Only a planet roughly the size of Earth has a gravitational pull strong enough to retain an atmosphere like our own, containing oxygen needed for combustion and respiration, but weak enough so that it won't retain its primordial hydrogen.
Our Earth is big enough to retain heavy molecules like carbon dioxide and oxygen and water vapor and things. It's got enough pull to keep them in, but it lets the hydrogen helium go. You need a rocky planet, something of the size of the Earth, to have an atmosphere like ours which will support respiration and combustion.
In order to harness the most important benefits of fire, you also need the right kind of fuel. Fuel that can generate fires with sufficient heat. Working with iron typically requires heat in excess of 2100 degrees Fahrenheit or 1200 degrees Celsius. You can't achieve or maintain that sort of heat simply by burning grass or branches. You need coal or charcoal or something equivalent. But the existence of such fuels depends on the flourishing of large, woody plants. Those plants in turn are made possible by a molecule known as lignin. Lignin strengthens cell walls, allowing plants to grow taller, and it slows the breakdown of organic matter in the soil, providing a soil rich enough to support large trees. Many scientists also believe lignin facilitated the creation of vast deposits of coal in Earth's history by preventing the breakdown of organic matter until it could be fossilized. According to Denton, without lignin there would be no woody plants, no wood, no coal, no charcoal, no fire, no pottery, and certainly no iron and probably no other metals or metallurgy. But therein lies an even deeper mystery. For the human use of fire to result in new technologies, nature had to be seeded beforehand with compounds and elements with powers that could be unlocked by fire. Such materials don't have to exist, but on our planet they do, and they exist in abundance. According to Denton, it's as if the materials of nature themselves were prepared beforehand to facilitate our technological development. It's not a new thought.
All this life upon our Earth has led up to and culminated in that of man. Alfred Russel Wallace.
Alfred Russel Wallace was co-founder with Charles Darwin of the modern theory of evolution by natural selection. Unlike Darwin, Wallace believed that evolution had been guided to produce animals like human beings, and to produce a world where humans could flourish. In his book, The World of Life, Wallace wrote about the key metals that supply the basis for modern technology, like iron and copper.
All of these are widely distributed in the rocks. They are also obtained from their ores without much difficulty, which has led to their being utilized from very early times. Each of the metals has very special qualities, which renders it useful for certain purposes, and these have so entered into our daily life that it is difficult to conceive how we should do without them. Without iron and copper, an effective steam engine could not have been constructed, our whole vast system of machinery could never have come into existence. Wallace asked whether it was just a fluke that key metals were so useful to man and so readily available throughout the Earth. Is it a pure accident that these metals, with their special physical qualities which render them so useful to us, should have existed on the Earth for so many millions of years for no apparent or possible use, but become so supremely useful when man appeared and began to rise towards civilization? Wallace didn't think that the existence on our planet of materials necessary for modern technology was just a fluke. He even argued that science itself was dependent on natural capacities pre-built into the chemical elements and compounds from which our world is constructed. To take just one example, Wallace highlighted the critical importance to scientific discovery of the chemical compounds that make possible the production of clear glass. Although most of us probably take it for granted, clear glass has been essential to the development of modern science. Without its use in bottles, tubes, etc., chemistry could hardly exist, while astronomy could not have advanced beyond the stage to which it had been brought by Copernicus and Kepler. It rendered possible the microscope, the telescope, and the spectroscope. Three instruments without which neither the starry heavens nor the myriads of life forms would have had their inner mysteries laid open to us. According to Wallace, the serendipitous features of natural materials pointed to a cause beyond physical nature. We are brought face to face with a body of facts which are wholly unintelligible on any other theory than that the Earth and the universe of which it forms a part was constituted as it is in order to supply us with the means of exploring and studying the inner mechanism of the world in which we live, of enabling us to appreciate its overwhelming complexity, and thus to form a more adequate conception of its author and of its ultimate cause. And it is impossible to conceive of that cause as other than an all-pervading mind. Like Wallace, Michael Denton believes that humanity's amazing technological success has not been due to our own genius alone. It's also the result of finely tuned conditions and properties of matter that make our technological advances possible.
So there's a huge number of conditions that must be satisfied in nature for beings of our biology to thrive, to thrive and live on a planet like the Earth and make a fire. It's a vast chain of coincidences in nature, and each one's a close call.
We have reaped the benefits of the technological revolution enabled by our mastery of fire. But our potential to make and use fire seems to have been built into our bodies and into the Earth's biosphere from the very beginning.
Okay, let me try to resume the review the argument here. This is mostly about the local fine-tuning, why the conditions on Earth are so good, but he mentions that there are some global fine-tuning parameters involved here too, but toward the end. But it's mostly about local fine-tuning. Remember back when we first, if you were here last time, we first talked about the local fine-tuning, and I said, well, why do we even bother? You know, if you can explain why the Earth is so nice, habitable, by saying that, well, there's many planets, there's bound to be some of them that are habitable. Well, I said, well, there's two reasons. One is that the Earth is so rare that it may be the only one in the universe, so maybe it's not, but that's hard to, hard to argue. But the other one, I said, well, we'll see that in 2b, and here's the argument here, is saying that there are a lot of things built into the Earth that aren't necessary for us to exist. You know, we would still be here to wonder about it if we didn't have all this metal ore. The metal ore was totally useless as far as we know until man came along, and very useful now. And the ability to master fire also, I guess. So it's this Behe's lush world. There's a lot more to the Earth than you can explain by just saying, well, if it wasn't such a nice planet, we wouldn't be here. there's, as I said in the video, there's the only explanation for these fine-tunings is they're gifts from our designer to challenge and entertain us, and that Denton's kind of illustrating that. For example, the heavier elements, metals, copper, uranium, and so forth, I'm not sure that those are necessary for life. Maybe copper is, but they are, useful for scientific discovery, for technology. So I think, God has built into the earth not just the bare minimum, so you can't really explain it by saying, there's lots of planets and some of them are bound to be habitable, but they're not bound to be this habitable, and then now I want to show I've got a 15-minute, that'll bring us just about to the 7:30, and then we'll take a break and we can have discussion then after the break, or you can go at 7:30. But I want to show you another segment from The Privileged Planet that talks about the scientific the fine-tuning for discovery. And again, this goes against the multiverse. The multiverse doesn't explain this. There's a lot more, the world is a lot more lush than you would expect by just saying we're here because the parameters are right.
The relationship between eclipses and scientific discovery was also revealed in the spring of 1919. On May the 29th, research teams headed by British astronomer Arthur Eddington photographed the Sun and adjacent stars in the Hyades star cluster during the darkness of totality. Later analysis of the pictures verified that the Sun's gravity bent light from distant stars traveling toward the Earth at the angle Albert Einstein had predicted. Einstein's theory of relativity, an idea that revolutionized our understanding of the universe, had been confirmed during a total solar eclipse.
And that experiment was only possible because the stars become visible during a total eclipse. They're very important in the history of science. And the best place in the entire solar system to view solar eclipses is from the surface of the Earth. I've actually calculated the circumstances for eclipses from all the other planets and all the other moons, about 65 of them, the major moons. And it's an amazing coincidence. The one place that has observers is the one place that has the best eclipses.
Within the gossamer light of a solar eclipse, Gonzalez and Richards recognized a fascinating connection between the factors necessary for complex life and scientific observation. But was this merely an isolated fluke of nature, or a glimpse at a principle and a purpose fundamental to the universe as a whole?
That was the million-dollar question that we continually had before us. What if those things that make a planet habitable also make that planet the best place for making scientific discoveries? That is, what if those rare locations in the universe that are compatible with observers like ourselves are also the best places overall for making observations?
For 3 years, Richards and Gonzalez meticulously tested their idea against evidence gathered from a wide range of scientific disciplines. In the 2004 book, The Privileged Planet, they published their hypothesis. The same narrow circumstances that allow us to exist also provide us with the best overall setting for making scientific discoveries.
In the book, we detail more than a dozen examples of this correlation between life and discovery. And these aren't quirky, marginal examples. Each treats a condition critical to its respective scientific field. Some deal with remote things, like the nature of galaxies. Others are much closer to home.
While a perfect solar eclipse was the catalyst for Gonzalez and Richards' hypothesis, their observations would never have been possible without another, more familiar example of the correlation between life and discovery: the atmosphere of the Earth.
It's striking when you see pictures of the Earth from the Apollo missions or other spacecraft, and you see this very thin layer of the atmosphere surrounding the Earth that sustains all the life that we know on Earth. And so you need a certain mix of elements to support a complex biosphere like ours. Not just any atmosphere will do.
Our appreciation of the Earth's atmosphere has increased significantly during the last 40 years, as exploratory spacecraft have probed the solar system. These missions have confirmed that within the Sun's family of more than 70 planets and moons, the Earth is one of 7 bodies enveloped by a thick canopy of gas. Yet among these 7, only the Earth's atmosphere can sustain complex life. And only the Earth's atmosphere is transparent.
It's an atmosphere that's made up of mostly oxygen and nitrogen with very little carbon dioxide and very little other carbon compounds or atoms in the atmosphere that gives you a transparent atmosphere. If we had too much carbon in the atmosphere, we get hazes, organic hazes in the atmosphere, like you see on the large moon Titan, for example.
The dense shroud of gas that blankets Saturn's largest moon resembles the atmospheres surrounding Neptune, Uranus, Saturn, Jupiter, and the greenhouse cauldron of Venus. None of these alien worlds know the stars, or even offers a clear view of the sun.
Now, of course, if you were suddenly transported to Titan or Venus or to one of the outlying gas giant planets, the lack of a clear view of the universe wouldn't be much of an issue because you'd be dead. But that's precisely the point. If we're right, if the conditions for habitability and scientific discovery appear in the same places, then you're going to get conditions like you do on Earth, an atmosphere that sustains complex life like ourselves and also enables scientific discovery of the universe around us.
The virtues of such an atmosphere are continually tested. As the Earth moves through space, it is bombarded by radiation from throughout the universe. This radiation is emitted by the Sun and other celestial objects, including supernovas and distant galaxies. It reaches our planet in wavelengths described as gamma, X-ray, ultraviolet, visible, infrared, microwave, and radio. Together, they comprise the electromagnetic spectrum. Almost all of these wavelengths are invisible to the eye and either lethal or useless to organic life. Yet within this spectrum of frequencies, a thin sliver of radiation proves essential to plants, animals, and human beings.
In other words, there's really just a very narrow part of the electromagnetic spectrum that's going to be useful for living processes like photosynthesis. It's not as if life could have evolved to use gamma radiation or X-ray radiation or something like that. There's really just a narrow part of the spectrum that would be useful to life processes. Well, as it turns out, that's also the same narrow part of the spectrum that is the most informative about the various structures that we discover in the universe around us.
These specific frequencies that enable plants to manufacture food and astronomers to observe the cosmos represent less than 1/1,000,000,000 of a trillionth of the universe's range of natural electromagnetic emissions. Fortunately, it is the type of light our sun produces in abundance, and that most easily penetrates the filtering shield of our atmosphere to reach the surface of the Earth.
It's a remarkable coincidence that the kind of atmosphere that's needed for complex life like ourselves does not preclude that life from observing the distant universe. It's a surprise. It's something that you wouldn't expect just chance to produce. Why would the universe be such that those places that are most habitable also offer the best opportunity for scientific discovery?
In 1997, Guillermo Gonzalez began a study of the Earth's specific location within the Milky Way galaxy. It would eventually lead him to more evidence of a correlation between life and discovery.
Just as our location in the solar system is optimized for habitability, so is our location in the galaxy. We inhabit a spiral galaxy, which means it's highly flattened. It has a spherical bulge in the center, and it has spiral arms. And we live about halfway between the center of the galaxy and the edge.
Working closely with astrobiologists Peter Ward and Donald Brownlee, Gonzalez compared our position in the Milky Way to other regions within an often hostile galaxy.
The galaxy has a lot of dangers, and perhaps the most dangerous place in the galaxy is the galactic center.
Well, in the center of the galaxy, this density of stars is very high, and there are more supernovas and stuff, and there are things that could harass life right in the dead center regions of our galaxy.
You also have the giant black hole at the very center of the galaxy. And if it were to have a close encounter with a star passing near it, it would rip it to shreds and form an accretion disk around it and emit lots of radiation, particle radiation and electromagnetic radiation, gamma rays, X-rays.
While a black hole, exploding stars and deadly radiation would make complex life virtually impossible near the galactic core, the outer edge of the Milky Way poses other challenges to habitability.
In the outer regions, the situation is much more subtle. We live on a planet made out of iron, magnesium, and silicon, and oxygen. If we went in the more distant regions of our galaxy, out towards the outer edge, the abundances of these elements are lower.
There probably aren't enough heavy elements to build Earth-sized planets that can support life. So there's a happy median between the dangerous galactic center and the outer edge of the galaxy.
Gonzalez, Brownlee and Ward labeled this region, where complex life is possible within the Milky Way, the galactic habitable zone. Their theory was first published in 2001 and has since received growing acceptance among astrobiologists.
There's a lot more research that needs to be done to determine just how wide the habitable zone is. But I think there's general agreement that yes, there are definitely places in the galaxy that you cannot have civilizations because they're very dangerous. And there are places where you just have a very low abundance of heavy elements.
While these obstacles to habitability are minimized far from the core and edge of the Milky Way, Gonzalez has also identified large areas within the galactic habitable zone itself, which are less hospitable to complex life.
Even within the habitable zone in the galaxy, it's broken by the spiral arms, which are dangerous places. That's where most of the supernovae go off in the galaxy. That's where the star formation is taking place.
We don't want to be too close to a spiral arm. We want to be outside the spiral arm at about the right region of the galaxy.
It appears this is precisely where the Earth is located, in the relatively safe and uncrowded region between the Sagittarius and Perseus arms of the Milky Way.
Location is everything, and so we occupy that special place in the galaxy where habitability is optimized, threats are minimized, and we have enough building blocks to build an Earth.
Guillermo Gonzalez and Jay Richards have conducted research on another facet of the galactic habitable zone. They now argue that the Earth is also located in the best setting within our galaxy for astronomical research.
As it turns out, our position in the universe is not only critical for life, but it's also surprisingly important for making scientific discoveries. We're located near the midplane of the galaxy, a very highly flattened galaxy, between spiral arms in a region with very low dust extinction. While we are in the plane of the galaxy, that does not obscure a large part of the sky, so we can have very clear views.
For more than a century, this nearly ideal platform of observation has enabled astronomers to study the structure of the Milky Way. Looking toward the constellation Sagittarius on a clear night, for example, we see that the stars in our galaxy are not uniformly distributed across the sky. Instead, they appear as part of a concentrated band, a flattened disk of stars, dust and gas, 100,000 light-years in diameter.
The Milky Way band in the night sky is us looking edge-on into the plane of the galaxy. If we were living in the center of the galaxy, things would look much more spherically distributed. And so it will be very hard to distinguish things that are inside the galaxy from things that are outside. And it's also very dusty, much dustier towards the galactic center than it is in our region. And so the views of the distant universe will be much more difficult to obtain, to be much more compromised.
Similar problems would exist for astronomers working on a planet located within any of the galaxy's spiral arms. Here, denser concentrations of dust clouds and gas illuminated by stars would make it difficult to determine the shape of the Milky Way, or to distinguish the stars in our galaxy from the rest of the universe.
On the surface of the Earth, we're really in the optimum position for seeing both the nearby structure of the Milky Way galaxy, as well as seeing the distant cosmos as a whole. So once again, we see that the best location for habitability and for producing a habitable planet is also the best overall position for scientific discovery, in this case at the galactic scale. For centuries, the fact that we can discover things about the universe has really been something of a mystery. Why would beings like ourselves be able to discover a universe like this? Why is what we think about the universe, why would it correspond to the way things really are?
Our ability to discern and understand the universe is a fundamental part of what makes the universe tick, so that we're linked into it. This isn't just a sort of an accident, a trivial little byproduct. It is something that is linked to the great cosmic scheme of things. Now, I've no idea how that linkage works, why it's there, or anything of that sort, but I'm very, very struck by the fact that we can understand the universe in such exquisite detail and at such a deep level.
Okay, it's almost 7:30, but let me make one comment about this particular video, because there's a kind of a subtle point here that he's making that confused me at first. But it's mostly about the local fine-tuning, you know, that the Earth is not just suitable for living, but for viewing the universe, for scientific discovery, although there's some stuff about the global fine-tuning a little bit. But they point out in the video that the best locations, the habitable zone in the solar system and the habitable zone in the galaxy, the best locations for surviving, for existing, are also the best for scientific discovery, for observing the universe. Well, at first glance, I thought, well, you know, then that if they're the same, then you know, the fact that we're here does kind of explain it. But as Richard points out, he says, well, that's surprising when you think about it. It really is, because why should there doesn't seem to be any correlation between conditions that will allow us humans, conscious beings, to survive, and conditions that allow us to discover the universe, and yet there is. So that's the amazing thing, and you know, the implication is that God designed it, designed the universe, put us on the world where we can not only survive but thrive and do scientific discovery.